Hello everyone and welcome back. So we are going to continue with the series. In this series, we are trying to build a machine learning model to predict electricity bills. So we started with the data ingestion, data validation, data transformation, a model trainer, as well as the model evaluation. So those were the different components in our model. So in the previous video, if you have watched them, you can see how I tried to build all those components and try to sync them together so that they can work in tandem. So in this session, we are going to start building the prediction pipeline. So the prediction pipeline, the main function or the main objective of the prediction pipeline will be to take the user input. Then from there, it will try to pre-process the data that the user has. It will try to process the user input. Then after that, it's going to make the inference. Inference is just another way of saying it's going to make predictions based on the user input. So the prediction pipeline will be tasked at handling that flow of data. So with the prediction pipeline, then comes with the also with the web application. So to add on the prediction pipeline, we are going to use, or we are going to add the web application. And for the web application, we are going to be using a Flask. So we can build a web application, and this web application will be as an interaction interface where the user can interact with the model. So it is through this that the user can now input data, and from the data, the model is able to make predictions from that. So that's what we're going to be tackling today. So before we get started again, please consider subscribing, share this video to your friends. You can also like this video, comment also, because we would like to hear from you. Once again, I'm very thankful for your time. And with all that said, let's get started. So as usual, we're going to start by first importing the necessary libraries or the modules for this for the that will enable us to build this prediction pipeline. So for example, the NumPy, pandas, the pathlib, because we are going to use import because we are going to access different paths. Then the OS, the Cs. Okay, so we're going to use different types of libraries for this. Then we can also import a logging. Then I will also create a custom exception that will enable us to handle any sort of errors that might arise when constructing this prediction pipeline. So I'll from src. So remember, we created exception.py. So currently the exception.py is empty, but we'll just fill it later. But let us just import the module for that. So src.electricitybill.exception. So here we are going to import file operation. So I'll show you how we are coming up with this. So file operation error. Okay, so import logging, file operation error, and also we are going to import the load object. So that utils. So utils dot commons. Import load object. So with the load object, so when you go to your utils, so utils in the utils, the commons, we have the file load object. So we are going to use this to load our any file, any joblib file. Okay, that's why we are using that. So we are using this function to load a joblib file in our prediction pipeline. So we'll be using that function. So after this, we are going to create a class for making the predictions using the trained model. So create a class to make the predictions now using the trained model. So the trained model. So essentially, so class can say prediction pipeline. So class prediction pipeline def in itself. So here we'll just use pass. Then we are going to make the method that is going to conduct the actual predictions, where we are going to define the necessary paths and all that. So def make predictions, then self, that's okay. Then features. So features, remember, these are just the column names or the columns in our data. So here we are going to, I'll use the try block. So this try block will only be functional only if we construct or we make our own custom exception. So I'll show you how we can handle that. So here we need to specify the model path. So for the model path, so os.path.join. So artifacts model trainer, then model.joblib. So this one's supposed to be under quotation marks to define that this is a path to a file. Oops, model trainer, again we include this. Model.joblib, again we include this. Then now we can also define the preprocessor path. So preprocessor path. So remember that os.path.join. So our preprocessor, again, I think it's just in the same artifacts, then a model. So artifacts, I think this one is in the model trainer. So when you go to the artifacts folder, artifacts, so if you want to find preprocessor.joblib, then or you can just copy the relative path. And when you paste it here, so we have the artifacts, we have the data transformation, then we also have the preprocessor. Okay, I just do like this. So after this, we need to now load the train model and the preprocessor. Load the preprocessor object. So preprocessor object, load object, file path. This is the file path, and we also need to load the model itself. So load the trained model, then model.object, that's file path, model.file path. So remember, as the user input comes in, it has to be preprocessed first. It do not just go directly to make the predictions. So it has to be preprocessed initially, so that as the way we pre-processed our training and the testing data. So it has to go through the same pre-processing. Then after the pre-processing, then it goes, and now we use the trained model to make the predictions. So that's why we are calling first our preprocessor object to do the pre-processing. Then after that, we use our trained model to make the predictions. So so the transformed features after the preprocessing object. So we can say, just name this features transformed. That is the preprocessor. I will just use the preprocessor object, then transform the features. So the features. Then after that, we make predictions. So predictions model.predicts features that were transformed. Okay. Then after this, we need to return the predictions. So I think everything is now okay. Then after this, we need to make our exception. So exception as E. Then we are going to exception exception as E, then exe. Then here we can say file operation error, then E comma Cs. Okay, now let's go to the exception.py, and we build our own custom exception. So under the exception, so again import sys. So import sys. Then we define the function that will extract the error message detail. Method to extract error message detail. Extract error message detail. So here if error message detail. So this is supposed to be error message detail. Then our parameters will be the error, then the error details object, we will be using a sys. Just do like this, sys. Then this is the method itself. Then from here we are going to get the testback information. So get the traceback information from error detail. So here we'll just skip those because they are irrelevant for this case. So I think this is the execution testback, and then we call our error message detail. Error message detail. Error details, supposed to be error details object. So error details object. Information, so that's okay. Then after this, we need to now extract again the file name from the testback. Okay, from the traceback that we are raising. So file name supposed to be underscore tb. Then let's go frame dot f underscore code. I think that's okay. Dot go file name. So that's the file name. Then after this, we create a formatted message, error message. So from the formatted error message, it will contain, so we can say formatted error message, and this it will contain the file name. So it will contain the file name. Let's include these brackets. Then it will also contain the line number. So we can say line number. So the line number this will contain in this. Then I can just include a square brackets. Then the error message itself. Okay, the error message, that will be the error, and I'll just include the square brackets. Then you can return the formatted error message. So I think that's it. So if you want to explain this code, or if you want to learn what this code is doing, you can just click on the explain. Then you'll get a message on this taskbar, and you can get further details as to what the code is doing. So the selected code is a function named error message details that takes two parameters: the error representing the error message and the error details object representing the Python sys module. This function aims to extract detailed information about the error. So that's why, remember, we are creating our own custom exception. So we are going to use this custom exception to enable us to raise any errors within our code, including the file name, the line number, and the error message detail. So you can see the function starts by us importing the sys module. Then it defines the error message detail function, which specifies the different parameters, the error the error representing the message, and the error detail object representing the sys module itself. So after we are using inside the function, we are creating other lines of code, and this the first one is it retrieves the traceback information from the error details object using the error details object execution information. I don't know if I'm correct in naming that. This returns a tuple containing the exception type, the value, and the traceback object. Then after this, the function then extracts the file name. As you can see, we have also included that in our error message. So the file name from the traceback using this, okay, that we have defined. Then it creates a formatted error message using an F-string formatting. You can see the message includes the file name, the line number, and the original message error message. So the file name, we are able to go to the exact file and see. We are able to see the exact file where the error is coming from. That's the file name. The line number, as you can see, we have the line number. So the exact line number we are able to pinpoint. Then the original error message, so the type of error message that it's raising. So we are able to read that message, go to the line number in a specific file to able to correct that. And finally, we return the formatted error message. So that's what this function or this method that we created is or will be doing. Then, so we need to define our custom exception. So we're going to define the custom exception itself. So define the custom exception. So for the custom exception, we define the custom exception. So custom exception. So class. So that's where the name file operation error is coming from. So file operation error. So that's where it's coming from. So file operation error. Then we need to include the exception. So exception is the exception. Okay, that's okay. Then we can create a def init. So the constructor. So def underscore init underscore. Then here we can say self a formatted error message. So the formatted error message. Then another thing is the error details object. So details object. Then from here we can again use the sys module. Comes in handy while constructing this. Then we can use a class constructor to set the error message. So we can say call a class constructor to set the error message. So that is it. So it's supposed to be class class constructor to set the error message. So super.init formatted error message. Then from here we can call the error message detail function. So error.formatted error message. So here we can say again error message detail. Then can include this into a brackets. So that is the formatted error message. Then error details object, just error details object. We can use this. Try to squeeze this. Then so formatted error message detail object, error details object. We can just do this. We're getting an okay. It's now correct. Then after this, we can then override the string method. So here we can override the string method to return the formatted error message. To only return the formatted error message. So override, supposed to be override. Okay, so after this, so everything self, then we can only return self.formatted error message. So this is how we can construct our own custom exception. So for this, again, we can explain what is taking place. So the selected code within the open file is part of the init method of the file operation error custom exception class. This method is responsible for now initializing the custom exception object with the formatted message. So you can just read through and find out what this class is doing. So overall, this code snippet demonstrates how to create a custom exception class in Python that includes the formatted error message, along with additional information such as the file name, the line number, and where the exception occurred, as the way we discussed earlier. And for this, we are just trying to skip. So the string method is a special method in Python that is called when the object is converted to string. So in this case, it is used to return the formatted error message that was created earlier. So this one here. Okay. So by overriding this method, the file operator error class can only provide a custom string representation of the error message. So we created our own string, and that's what we want to be returned when we are going to raise an error. So that's why we are trying to override what is the custom. So by that, we are making it easier to print and log the error details. Okay, so we can try our custom exception to see if it is working. So let's let's try to raise an exception. So if __ main, then we need to include logging. So again, from src.electricity bill, we are going to import logging. Import logging. So logging division by 0 error. So let's try to see if you're going to get an error. So I'm going to execute this file. So we create a new terminal, and in this terminal, so Python, then exception, copy the relative path, then just paste in the terminal, and see. You can see we are now raising this error division by 1. Then if you go to the logs, I think this one here, you can see we are now raising this error, info division by 0 error. So you can see our error is working. Our exception, our custom exception is working. So I think we don't need this. So we just need this if we are trying to raise a custom exception to see if our exception, our custom exception is working. You can see it's now working. Okay. So going back to our prediction pipeline, you can now see that we are able to raise the file operation error, where it's coming from, object where it's coming from. We can also maybe include a logging message. We can also include a log message, logging info, making predictions. Then we could also include another one here. So prediction pipeline. So after this, then the next thing, we are going to create class for custom data. Create a data class to represent input features. So we're going to create a class to represent the input features. So the input features are just the input features are the columns in our data. So class can say class custom data. So custom data def init. So for def self. So here instead of listing all the columns in your data, you can just use the quags. So remember the args and the quags when learning Python. So from here, you can just initiate the attributes using the quags. So initiate the attributes using quags. So this one is saving us the hassle of typing all the input features. So you can say for example, for key value in quags dot items. So they are in something like a list. So items. Then from here we need to set the attribute, self, key, and value. That's okay. So we can do away with this. Then after this, we need to again define another method. So define a method to convert data object into a data to convert data object to a data frame. So the custom data features, again, if you explain this, let's see what it's telling us. As custom data, this class is designed to represent input features for machine learning model. The init method of the custom data class, the code uses the quags parameter to initialize the attributes of the class. The quags parameter is a dictionary that allows you to pass any number of keyword arguments to the function. So as you can see, it's preventing us from listing all instances. Okay, so inside the init method, a loop is used to iterate over the items in the quags dictionary. For each key value pair, the code uses the set attributes function to dynamically set the attribute of the class with the corresponding key and the value. So by doing this, we are able to create an instance of the custom data class and pass any number of attributes when we are initializing it. Okay, so it's essentially, if this word jargon is quite hard to understand, just know that we are not trying to list all the attributes here. We're just using the quags to enable us shorten that process. Okay, because with the quags we are able to list any number. As you can see, we are able to list pass any number of attributes when we are doing the initializing. Okay, define them. So get data as data frame. So you can say here get data as a data frame. So after we get data as data frame, so get data as data frame. So self, again we initialize our try block. So here we're just going to log message, convert the data object into a data frame. So data key and value pair comes in form of a dictionary. So so here we will specify let's say the key, then get the attributes self dot self comma key. Then from here you can say for key inverse self, that's okay. Then after this we need to convert the dictionary to data frame. To data frame, or instead of we just do this in the return method, in the return. So here we can say so return pd data frame data dictionary. Okay, so to minimize writing an extra code. Then in terms of exception, you can just use this one. So this can just use the exception. So this is the prediction pipeline. This is so when we try to explain this, so this class is designed. So this class is designed to represent input features and provide a method to convert the data object into a pandas data frame. Okay. So we are converting instances of the custom data class into a pandas data frame, handling potential exception and logging the conversion process. Okay. So these two methods are working simultaneously. So let me just do this. So that's it. So we have successfully built our prediction pipeline. So let's go to the app now, app.py. So here, from here, we can now start a web application. This is now where we start building our web application. So I'm going to import the necessary libraries. So from Flask, import Flask request and render template. Then we also need import OS. We also need sys, so import sys. And also import necessary libraries. So again, from src electricity bill so we are going to import our prediction pipeline. So for pipelines tip number 6, prediction pipeline, we're going to import custom data. Supposed to be custom data. So supposed to be custom data. So that's okay. So exception prediction pipeline app.py. So it's supposed to be custom data. So that's the prediction pipeline. Then we can also import the exception. So again, from SRC, our custom exception, that is electricity bill dot exception. We're going to import file operations error. So after we're done that, we can now start creating our Flask application. Create a Flask application. So application, you can call it Flask. Flask name. Then you can just call up application. Get the Flask app application. That's okay. Then we can create a route for the home page. Route for the home page. So with this, you can say so app dot route. Then that's it. Then instead of home, you can use the index. Then from the index, we can return a render template. So render template will be our index.html. So ensure that we have the templates, a folder called templates, and in the folder templates we have the home.html and the index.html. So the index.html just contains a message like welcome to homepage, so that when we call this, then we are going to, when we return render template.html. So I'll show you the first way what we can do at first to render the index.html. So some form of message like welcome to homepage, something like that. Then so this is the route to our homepage. Then we can also create another route. So the route to train the pipeline. So if you just want to train the pipeline now from the app itself, so you can use this. So app.route. Then here we're going to train. So method I think we'll use get and not only use get. So methods get, then def train if request. Then here we can use another. So you can say os dot system. Then say Python main.py. So remember our main.py. So when we are just going to train our pipeline, we're just going to call this method main.py, and the training instance takes place. Then after this, we are going to return something. Return maybe a render template index.html. Let's return a message, or you can render another template. Let's say, let's create a new template here. So let's create a new file, and this file, let's say, call this train.html. Okay, so train.html, and then in the train.html, what we are going to do is we just copy such a message into our train.html, and then we can say training successful. You can just check the spelling. So so when we do the training from the web app, then and So when we do a slash train, then we are going to render the train.html. So train.html file, and this, it will display the message train successful, training session successful. So that's okay. I can just do away with this. And then after this, we create one for prediction. So route to predict the pipeline. Then app.route. So this one is for the prediction. So when for the route.home homepage, so again, we try to explain this. The selected code snippet is part of the Flask web application, and this code snippet a route is defined for the homepage of the web application. So we are creating, this is the decorator that specifies the URL route. Then index, this is the function which will be executed when the route is triggered. So when we trigger this, then we are going to use this method to trigger, to execute. And the function name index is a conventional name for function that handles the homepage of the web application. Then we are going to return something. So this line code uses the render template function from Flask to render the HTML named index.html. So from there, it will now display the message that we've specified earlier. The same thing happens to the training pipeline. So again, this route is possible for training the machine learning pipeline. So remember, we had the main.py. So the line defines the Flask route that matches the URL path train that accepts a GET request. So this one again is the function that will be executed when the GET request is made. And after that, we have this. So this line uses the OS systems function to execute the command by this one. So after this is done, after the training is done, we are going to return some message. So this line returns the rendered HTML template, this one. So the rendered template function is a built-in, okay. The selected code snippet uses the Flask routes for the training machine learning pipeline. When the GET request is made to the train endpoint, so the train function will then be executed, which runs the main.py, as you saw. So the main.py is our main point where we can execute the model itself. So we are going to use that to train script to train the pipeline, and then returns the rendered HTML template for the training process. Okay, so now let's complete this by creating the route that will enable us to make the predictions. So up to route predict method. So for the predictions, up to route predict method post. So here we'll use the get and the post. So get. So get comma post. So diff predict. Predict and data point. Data point. So def predict the data point. That's it. So then we need to include some function here. So if request dot method then is for get, then we are going to return render template home.html. So we are going to return home. I'll show you what is in the home.html file. Else. So from the else block, we are going to now include our try block. So else. So else like this. Then try if. So we first need to. So try block. Just do away with this. So in our try block, so the first thing is we are trying to initialize an empty dictionary to store the data. So initialize an empty dictionary to store the data. So inside here, so we are getting something like a form data. So that's supposed to be a dictionary. Remember to use the squiggly brackets. Then after this, we need to iterate over form fields and populate the dictionary. So in this case, so you can use a for loop for field in. So inside here, we're just going to paste all the column names. So fan, refrigerator, air conditioner. So these are our features our features in our data. Okay. So tariff rate, all that. So after this, we need to. So for that, we are going to say form data. So form data field. Then here we can say we are going to get a request.form. So request dot form dot get to brackets the field. Then create custom data object using the quirks. So remember we created that. So create custom data object. Here we are going to using the quirks. So we can say something like custom data. So custom data equals custom data form underscore data. That's okay. Then after this, we need to convert the form data dictionary to a data frame. So remember the function that we are using in the prediction, this one, get data as data frame. So we are using that to convert the data dictionary into a data frame. So you can say thread df. So we are going to use custom data dot get data as data frame. So create custom, okay. Then we can do some printing. So print the data frame for debugging process. So if you want to do some debugging of your data, debug as double G for debugging process. Then we can say print PDF. That's okay. Then another thing, you can use a log message. So log message at this point, we can say logging info form data, say form data before prediction. Then what we can do, we need to import that. So we can say, yeah, from CSRC build import logging. So it's supposed to be logging. We can use something else. Print, we can use message print before prediction. Let's see. Just adding it so that it's able to tell us if we are So we are going to initialize the prediction pipeline. So prediction pipeline, prediction pipeline, prediction pipeline, prediction pipeline. Then you can use another log message. Login info. That's okay. Here we can say mid prediction. Home data mid prediction. Then after this, we need to get the predictions. So make predictions. So we can say predictions, prediction pipeline, predict spread df. So prediction pipeline, this one here, prediction pipeline, make predictions. So we're using the function make predictions from predict df, this one here. Then we can also add another log message. So log message, logging info, and say after prediction, so that's okay. Then we can return results. Return results. So results we can let's say return render template home HTML predictions. Predictions. So prediction. Yeah, that's okay. Then after this, the accept. Exception as E. File operation error as E. So undo. Let's try to squeeze this. Nope. Let's try to squeeze this. Exception as E. Then let's try to run our Flask app. So if name underscore main app.run debug true, then we can use host and create our host. So 0.0.0.0, then debug be true. So this is our prediction pipeline. So I'm going to create. So from here, we are going to execute our code, and we want it to run from here. So we can say, let's say sklearn, something like that. So we want to execute it from there. So we can save this. So now let's go to the home.html. So in this file, so you can this is the code, the HTML file. So you can see from the HTML it contains the different. So I did some styling here and there, and then you can see the electricity bill predictor. So a method post. So the number of the number of fans. Refrigerator, so the number of refrigerators, number of air conditioners, number of television, number of monitors, number of I think it's uh, I think it's supposed to be, let's say, uh, supposed to be electricity supposed to be cargo. I think it's this one. So what's I don't think it's supposed to be number. It's supposed to be hours. It's a comprehensive captures the electricity consumption pattern for Indian household. It includes information about the number of hours of each household appliance. So it's supposed to be number of hours, number of hours. So how can we call this? Number of hours of each household appliance. Number of hours of number of hours. So number of hours. So we just change this. So you can use. So I suppose this is the number of hours this appliance was on. So month. In a month. So these are the cities, different cities. So options for the cities. Also, these are the number of the different options for the companies. So if you go to electricity bill, so let's wait for that. So monthly hours. So this is not number of month. This is supposed to be just month. The 10th month, the 11th month. Okay. So monthly hours. So you can say total monthly hours, tariff rates. Then we make our prediction, something like that. So in this case, number of hours of monitors. I'm trying to find a better word to describe this. Additionally, it compress. Okay, the rest is to predict. Number of hours funds in operation. You can say something like that. Number of the funds in operation. Of funds in operation. You can say number of operation hours. Number of, say, operation hours. Then you can just use this comma and just say, okay, something like this. Number of hours. So funds. Number of hours for the refrigerators. Okay, number of hours for air conditioner. Number of operation hours. So, okay, number of operation hours for the television. Number of operation hours for the monitor. Number of operation hours for the motor pump. Month, just the month. Again, companies, just the company. Monthly hours, total monthly hours. Tariff rate. Then we create a button to predict. Then the prediction like this. Okay. So this is the HTML that we are going to use this HTML to input data. Okay. I think everything is okay. Let's try to execute this. Okay, so let's see if we are going to get something. So I'm going to execute this. Let me create a new terminal. So a new terminal. From the terminal, you can say Python app.py. Just yeah, let's wait and see. So we need to execute this. Private network can allow access. Then we are getting this link. So you can just copy this and maybe open this. So we are opening it here. Let's see. So initially the 127.0.0.1 colon 500, it will be leading us to our homepage itself. So it will be leading us to our homepage. So our homepage, not the index page, something like welcome to our homepage. So that's what we are expecting. Let's just wait for it to load. So we're expecting it to lead us to the homepage. Homepage is the index one. So when we execute that, we are supposed to bring us to the index. We are supposed to see some message like this: welcome to homepage. What's something, as you can see, we are getting the welcome to homepage message. So you can see our app is working. So if we want to train our model, so remember when we create the route to train the pipeline, so we can include a slash train. So when we include the slash train, we will be training our model. So let's execute that. So this is going to send a request, and in that request we are going to train our model. In that request we are going to use this. We are going to execute this Python main.py, and once we execute the main.py, you will see that we are will be training our model. So let's just give it some time for us to train the model. Then after we train the model, I'm going to try now to do the prediction pipeline. So after we train the model, we need to get some message. The message should be the train HTML, training session successful. So that's what we should be getting. I know it's taking some time, but we just give it some time for it to complete. No, why it's taking some time, but let's be patient. As you can see, we're getting the message. Training session that was successful. So I think our model is working okay. So you can see the training that was taking place in the background. So this is the training that was taking place. Okay. So you can see this. So let's try now the last part or the last bit, which is all about now how the user can interact with our model. Now we use the slash predict. So this one will render the templates that the user will now use to make the prediction. So slash train, so predict. You're going to get such a thing. Okay. So from here you can insert the number of hours. Let's say you search 2 operation hours. You can say, let's say 15. The number of operation for air conditioner. You can say 22. Number of operation television. You can say, let's say 5. these people don't like watching television. For monitors, again, you can say 5. The number of operation for the motor pump, you can say maybe 1 hour. Enter the month. So month, for example, you can say the 5th month, or the 5th month, which is May. Then city, you can let's say you can try New Delhi. Company, we can say Torrent Power. Monthly hours, we say 389 hours. Tariff rates, we can say 9.48, something like that. So let's see if you're going to get our prediction. So when we execute the predict button, again, it's going to take our data. Oops, getting an error. While operating this, getting an error somewhere. Let's go back. So this one will tell us where we are getting the error. Press back. Response. So error modules is so we are getting an error after mid prediction. Object transform features. Object transform features. Let's see why we are getting the error. Try to do this. So pred.df. So custom data. That's okay. From data, pred custom data.get data frame. Okay. So we forgot to add that thing there. So I don't think this is the problem. So the challenge was coming. Error module info making predictions. Error. So after making predictions, info making predictions. Okay. So we forgot to add this from data prediction. So before prediction pipeline. Prediction pipeline. Make prediction spread df. Okay. And login, no problem. And template home.html prediction. Then can add something like this. So let's see. Let's try it again. Let's run this. Make sure you have saved. Then just clear the screen again. So open the new terminal. You can say Python. That is app.py. So let's see. When we run this again, we're supposed to use this. So I'm going to execute this again. Do this. Then we're just going to do /predict. So we are going to do /predict. It will bring us to this page. Number of funds. So number of operation hours for the funds. So this one you can say. Let me not try to shoot over and beyond. Fund we can say 16. It's around 23. So for the fund we can say 16. Let's use 12. Number of this one 23. Let's use 25. Then for air conditioners, let's use it's about 2.0. Let's use something like 5. For the number of operation hours for the television, let's use 8. Number of monitors, let's say monitors we can say 7. Pump, let's use 1. Month, the 5th month. city New Delhi. Company, we can use Unitech. Monthly hours, let's say 390. Tariff rate, let's say 7.8. So you can just use arbitrary numbers for that. Let's do again the prediction. Don't know why you're getting error. So tariff rate, no, we are prediction. Predicts, why are we not getting the output for that? So you can see fund prediction, New Delhi transmission, power at 97.8 tariff rate. This is the output for that. Login for form data mid prediction, making predictions, form data after making predictions. This after prediction, post prediction. This let's see. Let's try to format this HTML file. So format HTML file online. HTML. Let's paste file here. Use for format. And just copy this, then go to our file, home.html. You can just paste this here. Then we can run this file again. Control C. Let's clear the screen. Now you can say, after we save this, you can say python app.py. This is always a tough challenge. Always a tough challenge in this section. Then I will use this, and then it will bring us to this page. So after that, we do a slash predict number of hours. This one you can say number of fans. Let's say 4 refrigerators, 5 number of air conditioners, 12 number of television, 7 number of operation hours of monitors. Let's use 0. Monitors, let's use 15. Let's use 0, 5. Hyderabad, OptiBelt, number of hours, let's say 380. Tariff rate, around 7.8. Yeah, say 7.8. Okay, so let's again, we are not getting the output being displayed. Let me try something. Let me try to format this home.html. Don't know why we are not getting. We need to get the prediction. We need to get the prediction itself, but we are not getting that. The file is executing okay, but we are not getting the. We need to get the prediction. We need to get the prediction being displayed. Let's see what we are missing. So I'm trying to debug this code. Okay, so there's something that you're supposed to get results, and the results supposed to be prediction, if I'm not wrong. So prediction. we need to route correctly. So route predict method post, method get post predict data point. So if request is equal to this, render home.html. In the HTML, we need to ensure that predict method posts. So this one is method is post, form action, control find predicts. Seeing language. So viewpoint content, electricity bill prediction title, style body, then electricity bill predictor. So form action. Supposed to be result. If result is this, if class result prediction bill result div. So we were getting an error. There was something that there was an error in terms of our method trying to display the prediction. So in terms of the error, I solved the error. Now it came in terms of I had the mismatch in terms of prediction. So I had I changed something also in terms of how we are going to display the message. So the prediction should be much in line with what we are trying to return here, the render template itself. So here we're using prediction. So make sure the same case you're using prediction. So from here you can now able to make the prediction itself. So let's try to execute this file once again and see if you are going to get the predictions. So I'm going to repeat this process again. I want you to execute from this tab. So in this section, I'm going to Control C just to end this process. To end this process, Control C to stop the initial process. Then after this, what we can do, we can make sure we have saved everything. So this one is not needed, exception not needed. This one is not needed, exception app.py. Okay, so we can clear the screen, the terminal. Then let's execute this once again. So we can say so Python app.py. So let's execute this, and we should get our link. Then when we try to access that, it will take us to a Google web browser. So from here, let's make sure that we are going to get our message here. So Indian, let's say, okay. So from here, we go to this link, then just control, then click on the link. Then return home page. Then we can use the predict. So when we execute the predict, the number of fun hours, I like to be a little bit not to shoot very fast. Let's try inputting values very close to this and see if we can. Well, let's try arbitrary values. There's no need, not a must that we follow that. Number of funds. We can say number of funds. For example, we can say instead of 16, let's say 18. Number of refrigerators, we can say 25. Number of air conditioners, we can say 3. Number of television, let's say 7. A number of monitors, let's say 3. A number of operating hours for the motor pump, let's say 1. For the month, let's use 5 because we are in the month of May. For the city, Hyderabad, let's use Mumbai. Then for the company, let's use Orient Green. Then for monthly hours, let's do something like when they are predicting about 384, 500, let's say something like 420. Then for the tariff rate, let's put it at 8.1. Let's see, predict. We should be getting our prediction being displayed. So you can see the predicted bill amount is this 344.99 rupees. So the prediction amount is in form of it's in the Indian rupee. We're using data from India. So you can see now that we have done our prediction. You can see that by just inputting data onto our web application, we are able to get some some predicted amount based on the input data. Okay, so you can see you're getting this prediction. So this actually now you can see how we can actually now you have I assume that you do have an understanding of now building a machine learning model from just now from just a simple model that we had in our Jupyter notebook. Okay, just a simple model like this one. Where was it? The decision tree regressor now. So actually, all that we have been doing is we have been building the infrastructure around this code. That's what we have been doing. So from a simple model like this, we are able to construct something like this, where we have our web application, and from the web application, we are able to get the prediction based on the input data. So this is the web application. You can practice all along. Try different values to see what prediction you will be getting. So I think by now, I assume, or I'm quite sure that you have a full understanding of how to build an end-to-end machine learning, depending on the different, depending on the data that you are doing, or on any project that you are doing. So this is something like the basis of it. So you can use this now to try to add other things into your model. Okay. So you can now see that our model is working. If you try, if you, for example, try to execute the home page, you can see you're getting a result for that when you want to execute the training pipeline, and if you want to make a prediction. So you can see now our model is now functioning. So the prototype part of it is now functioning. So whatever it remains is all about now doing the prediction, doing the deployment. So you can do the deployment in different, you can deploy this to a server. You can also display or deploy this to edge devices, mobile phones, okay. So there are different ways or methods that you can use to do the deployment. But all in all, this is it for today. Once again, thank you for your time. Thank you for your patience in this journey while trying to build this machine learning model. I'm grateful for your time. So before we close the session, let's push this code to a GitHub repo. So I'm just Control C. Then we can do that. So add dots, git status. You can see the files that we are trying to commit. So we have the app.py, the exception, the prediction pipeline, home.html, index, and train. So git commit -m. So we can say web application complete, web app complete. Then we can do the git push -u origin main. Okay. So that's it. Now you have successfully built your machine learning model, and you can see that now it's now working. Starting from just a simple model, only a single cell in terms of code, up to now where we can have a web application where you can input your user data and you are able to get a prediction based on your data. So I'm going to end the session at this point. So if I will maybe I will add other things from here. Now the deployment part, we can convert our file into a container, so we can containerize this model using the Docker. We can also use the ML flow for I think ML flow for model I'm forgetting that word. So we can use the ML flow when you want to do data versioning. So for ML flow, if you want to do model versioning, you can use the ML flow. If you want to do the data versioning, now you can use the DVC and all other tools. So all other things come in terms of now when we will be doing the deployment. So I will be adding a little bits onto this model until all the way to deployment. So I'm going to end the session. Once again, thank you. I'm grateful for your time. Please, you can share this with your friends, with your colleagues. Please consider subscribing again. Like this video, and I would like also to hear from you, so you can write something in the comment section. Once again, thank you. See you in the next one. Bye-bye.